Alright, welcome back to ArmanisMath. Today we're going to focus on arithmetic sequences and series. Arithmetic sequences and series. Very interesting topic. And in it we're going to find out that there are some other areas in math that we don't focus on that much, but they're also equally amusing. And this one basically will be targeting the sequences and series in math, specifically the arithmetic ones, not the geometric and the other series. Okay, there are much more to this than we're going to discuss today. So first of all, I wanted you to look at this table here. So you have an input. Let's say this is x's, for example, and this is y's. If you look closely, you're going to find out that there's 0, 1, 2, all the way to 4. And there's some outputs as 1, 5, 9, 13, and 17. Okay, I wanted you to notice the following thing here. In math, with the word difference, or D in this case, will be the subtraction. So basically, you're going to subtract 5 minus 1. Tell me how much that is in the chat. And then you're going to subtract 9 minus 4, minus 5, I'm sorry. And then you're going to subtract 13 minus 9. And finally, you're going to subtract 17 minus 13. How much did you get? I see a lot of 4s here, which is true. So the first difference, it's called first difference. Or first subtraction. The difference in math is subtraction. Is going to be 4 and again 4 and again 4 and again 4. Because this is repeated, it's the same one, it's repeated. So we call that common difference. Common difference or common subtraction. So when you subtract these numbers, you'll end up with a common difference, which we gave it a label of D. Okay, so keep that in mind. That's how we get the common difference. You just subtract, let's say item number 2 minus item number 1. You go basically backwards. Number 3 minus number 2, etc., etc. Okay, so I wanted you now to help me. If I give you a table and you can find me the first difference, okay? And I'm going to do, let's say I want to do a table like this. I'm going to say 1, 2, 3, 4. And this one's going to be 1 and 3 and 5 and 7. Input, output. Find me the first difference and tell me if it's common. Good. And the common difference is, so somebody right now just told me the common difference is 2. Actually, more than one person said that. There's a 2 here. 3 minus 1 is 2. That's a 2. That's a 2. And these are common. These are repeated values. So the common difference, or D, equals to 2. Simple? Good. So that's the basic idea here. Arithmetic sequence, I want to point out a couple definitions here. Arithmetic sequence means that you take numbers and you have commas between them. You're just listing numbers. For example, I could say 1, 3, 5, comma. What do you think is going to be the number after that? 7, and then what's after that? 9. Good. So you probably are thinking I'm talking about odd numbers, right? Which is fine. That is odd numbers. Now, in sequences, there's 2 types. Sequences and series, actually. There is some finite, and there's infinite. Okay, so sequences. have finite. Finite, that means it's limited. You know the beginning and you know the end. For example, if I said I wanted you to do this sequence here, 2, 4, 6, and 8. That's it. I'm not going to do any more. Meaning I have a beginning and I have an end here. I begin, my first term is at this location here. My first term is at this location. My last term ends at here, at this location. So I know the beginning and end. That's why it's finite. It's limited. Can you have infinite series? The answer is yes. I could keep going. 2, 4, 6, 8, dot, dot, dot. These 3 dots. Yeah, take notes, Stefan. Take notes. These 3 dots here indicate that I'm going to keep going and going and going and going. Does anybody know where can I stop here? Where does this stop? If I kept on going and going and going and going and going and going. What do we call that in math? It doesn't stop, but what do we call that definition? Yes, exactly, infinity. It's going to go all the way to infinity. So that's why it's infinite. It's infinite. It's going to keep going. Now, for the other definition now, so now we know sequences, if it's limited, finite, or infinite. Now, how about the second item here? It says arithmetic series. Now, series are interesting. Series are easily described as you are summing up, you're adding up these terms. So, for example, I'm going to say for this series here, I'm going to say 2 plus 4 plus 6 plus 8. I'm adding them up. Okay? And when you add them up, you also know the beginning and the end. You have, this is a finite series. You know the beginning, you know the end. You add them up. Basically, that's what they're asking you. So in series, you need to look at this word. See S here, this S for series. And this S, you probably could think of it like a summation, like summation. You're adding things up. Also, another idea, or I should say another notation for series, for summing up series, is this Greek letter, which is sigma. So this Greek letter looks like this. Just like the S in English, this is a Greek letter for sigma. And that's the one that they use in math to sum up, to add up. So when they say something like series, they also could use either this summation, or they also could use this sigma in Greek. Sigma. And I have more information on this, okay? But for now, just know that they have the sigma in Greek used to sum up, to add up these series. Now also go back at the top here. Series have also finite, like the one here, and they also have infinite series. For example, I could say 1 plus 3 plus 5 plus 7 plus, remember the one that you gave me, guys? Dot, 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 all the way to infinity. So how can you sum this up? Well, there is actually, you could use the summation here to do that. You could use the Greek summation to add them up. And you're going to start from some value here, right? Let's say that you could start at the first value here, all the way to infinity, for example. All the way to infinity. You're going to start from, let's say the first value here is 1, and you call that location 1. Perhaps it's I. They just use the word I for that. And you're going to start from the first location all the way to infinity, adding them up, adding them up, adding them up. Okay? So I need you on your whiteboard, give me a finite sequence. Give me an example of finite sequence. Please don't use the one that I have here. Give me an example of finite sequence. It's easier to use the whiteboard, you guys, so I can see you. I would notice mistakes. Okay, remember I asked for sequence. I needed a sequence. My first question was, give me a finite sequence. Same thing, Juliana, finite sequence. Myra, that is good. I like that. Kennedy, that makes sense now. Yes, Natalie, that is good. Juliana, did you fix it? I'm asking for sequence. Yurishi, Come up, champion. Brianna. Yep, that looks good. Finite. You know the beginning, you know the limit, you know the end. So location number 1, okay? A lot of you giving me good examples here. Location number 1 would have an address, okay? Yep, I see that. So let me take one of your guys' example. I'm going to take Myra's example. She said 6, 12, 28, 24. Did I have comma, dot, dot, dot? Is this finite or infinite? This is finite. It's limited. I know the beginning, I know the end. And by the way, the beginning here has an address. So for example, if I named this series A, this would be A sub 1, the first address in this series. What do you think is going to be this guy here? A sub what? Yeah, it's the 4th. So it's this first, second, third, fourth. A sub 4. So in the series, in the sequences, series, you have locations, you have addresses for these entries. We call them terms. First term, second term, third term, fourth term. Okay. Now I need somebody to give me an example of a series. And this one, give me an example of infinite series. Infinite series. Natalie, pay attention. Are you giving me a series? Kennedy, that is good. Juliana, that is good. And then Lindsay, that is good. I like that. So this was a sequence again. This was a sequence. Finite sequence. And this was an infinite series. And I'm going to take Lindsay's example. So I'm going to say this is a 5 plus 10 plus 15 plus 20. And then did she stop there? No, she didn't. She said plus dot dot dot. That's why it's infinite. You're going to keep adding until you get to infinity. Okay, if I name this series A, who lives in A sub 3? Awesome. Yep, good job, Juliana. Good job, Myra and Yurishi. A sub 3 would be this guy here. This dude here lives here. A sub 3. Okay. All right, let's move on. If the common difference here, the common difference we talked about, if it's common, if it's the same, we call this arithmetic series. Arithmetic series. Just as simple as that. Arithmetic series. I'm sorry, in this case, sequence is what I'm talking about because it's commas. So arithmetic sequence, if you're talking about common difference, arithmetic sequence, as you see here, one listing of numbers with that. So how do you know the previous number? Well, you always have to look behind you and then add the difference. You look behind you, like one person behind you, and then add the difference. Okay, I'm gonna move on forward here. Here's some definition of something called recursive. So this highlighted word you need to write down. Recursive definition. Recursive. What does that mean? In recursive, I wanted you to pay attention to the prefix. The prefix recursive. So basically, you're looking behind you. So in recursive, this is me here standing in line. And this is the person behind me, perhaps shopping or something. Remember the social distancing right now? So this is a distance. This is the distance. This distance here is the common difference that we talk about. Distance is a common difference. So how do you do the recursive definition? It says each term is defined by the operation of the previous term. Basically, if you're standing in line, you have to look at the person behind you here, and then you add the difference between you and them. So the definition of the recursive is written like this: a sub 1, the first item, okay? And then if you want the next terms, you say a sub n minus 1, that's the person behind you, a sub n minus 1, plus the difference between you both. And that's how we get to the second person, and the third, and the fourth. So you always look for the recursive, you look behind you, and then add the difference between you both. Okay, so in recursive, it's kind of a like a piecewise function, the two pieces here. The first person you know, and then this, if you want some other people, that's fine. You just look behind you, and then add the difference between you and them. It comes with recursive. I'm gonna give you an examples on this, okay? So maybe have it like a stick figure or picture like this would help. Recursive means I'm looking at the person behind me and then I'm going to add the difference. And that's the difference here. By the way, a sub n sub 1 is the first one, right? What if you said a sub n minus 1? Well, you are the 1 and n is the number. So if you want the fourth one, then you look at 4 minus 1, which is the third, right? So n sub 1 means the person behind you, the previous term. Okay, more on this to come. So let's see, for example, here it says in the sequence 4, 7, 10, 13, is the sequence arithmetic? Well, you will have to put it in a table, and you will find out when you do the difference, the subtraction, it's actually going to be, yes, it's going to be a common, and that's why it's arithmetic series. Arithmetic sequence. The second thing they ask you, what is the recursive? Well, the recursive is defined as, one more time, the recursive is defined as two pieces. The first piece is what is the first term? Well, the first term when n equals 1, here, this guy here, that's the first term. So it's 4 when n equals 1, the first term. And then what's the next term? Well, this is what's going to give you the next term. A sub n minus 1, the previous guy, plus the difference, plus the d, just like it says up here. See that? The previous person, plus the distance between you and them. Okay. I'm going to move on to another concept, which is called the explicit. Okay, so write this down. Explicit definition is also written as a sub n equals a sub 1, the first term, plus d, which is the common difference, times n minus 1. So perhaps you need to highlight that one here, because that doesn't change. That's going to be the same. Explicit for arithmetic, it's going to be here, and it doesn't change. It's always a sub n equals a sub 1, the first term, plus the difference times n minus 1. And n is gonna be defined by whatever the sequence is. That's a definition of explicit. What's the benefit of explicit? Well, what's the benefit of explicit? You don't have to look at the person behind you. You could ask me, what is, for example, you could say, what is the 15th term? And all what you have to do to give me that is the a sub 1, the first term, like this guy here. You just give me a sub 1 and give me the difference. And that's it. I'm able to show you exactly how much is this person 15th entry, for example, 15th term, without me going through every single one of them at a time. I'm not going to keep looking at the person behind me for 15 times. No, this one here gives you kind of a shortcut to get exactly what you need in a short amount of time. So obviously explicit has its own benefit because it gets you exactly to what you need without you looking behind you every single time. Okay, so let's take an example on this as well. It says here, for example, given this explicit definition, a sub n is 16 minus 3. What is the recursive definition of arithmetic series? The common difference is, well, you look at this one here. The common difference, if you remember that this is the exact definition of, look at this one. That's a definition here. So see this, explicit? Keep that in mind. That doesn't change. So basically, if I were you, I'm going to write it on top of it. A sub n is a sub 1 plus the d n minus 1. Okay, so look at this. Let's try to match them here. What do you think is my d? What's the distance? What do you think is my distance here? It is 3. Right, it's right there. Right there. I should say -3 because there's a negative here, right? See that? There's negative here. -3. How about a sub 1? What's the first term in this sequence? What's the first term? Yeah, I don't have to guess. It's here. A sub 1 is going to give you 16. So basically, you give me a sub 1, which is again here. And that's going to give me the ability to do the recursive from there. Because I know a sub 1, which is that. And I know also it's a sub n minus 1 minus the 3, which is the d, the distance here. Okay, when is this actually used in real life? Well, here, let's look at this auditorium, for example. The use sequences in, for example, high school auditoriums, like the first row would be 16 seats in the first row, and then 26 seats in the fifth row, for example. So how are you going to find out the second and the third, etc.? Well, you could use sequences to help you with that. So that's a good example for you to look at. Let me focus on the last piece here, which is going to be pretty simple. There is a way for you to know, as I said, the sigma notation, and we're going to talk about this in a second. Okay, here we go. Let's focus on this one here, the concept summary. Recursive, we talked about recursive. So let's focus on this side here. Recursive is, once again, you look behind you, one person, n minus 1, plus the difference between you. Here's an example. If a sub 1 equals 1, if the first term equals 1, and the distance is 7, well, you could do a sub 2, a sub 3. Because a sub 2 is going to be the, once again, a sub, look at this one. It's going to be a sub n minus 1, which means 2 minus 1. This guy here. Let me write it down for you. A sub 2 minus 1 plus the distance. See that? What is 2 minus 1? 1. So you basically, you're saying a sub 1 plus the difference. A sub 1 plus the difference. Well, what is a sub 1? Well, they gave you that. They said a sub 1 is 1. What's the difference? 7. So that's 1 plus 7. Okay, now let's do more of the explicit. Explicit here. It says that this doesn't change again. Remember, it doesn't change. A sub n is how many in the formula. Explicit, and a sub 1 is the first, d is the distance, and n minus 1 is the number of terms minus 1. So for example, it says here for a sub 1 equals 90, if that's the beginning of your series, 90, and the difference is -4. Can you find out the second? Can you find out the fifth? Sure you can. You don't have to go one by one because you just could follow this here. So let's say, for example, what could a to the fifth be? Follow along with me here. A to the fifth. I'm going to use this here. What's a sub 1? What's a sub 1 in this one here? What's given to you? 90. Okay, remember, we're going to do a sub 1 plus difference of n minus 1. So if I said a is the fifth, okay, that's going to be a sub 1, which is what's given to me here, 90, plus what's the difference? Does anybody know the difference? Are we given the difference? That's negative 4. I need somebody else, not just Eurasia, to respond, you guys. Negative 4, that's the difference. And what is the n? 5, that's what you're doing here. 5 minus 1 is 4. Okay. So if you do that, what do you think I'm going to end up with? Somebody do the math for us here. 90 minus what? That's right. And how much is that? How much is 90 minus 16? Yep. So if you looked here, 60, 72. 70, 90 minus 16. 74 or 72? Subtracted from 100. Okay. 86 minus 82 is 4. This guy is 4. So I'm expecting to see something 74. See that? Because it's common. All right. And then the last one here is the arithmetic series. Series is you sum them up, you add them up. So here is the formula for the series. S sub n, you add them up in this format here. Is n times a sub 1 plus a sub n divided by 2. So once again, S sub n equals n, a sub 1 plus a sub n divided by 2. There is also another way to write it, which is here. That sigma part. See the sigma here? Sigma is a summation. And you're starting from, if you pay close attention here, there's an I equals 1. Well, that's the starting point. I'm going to start from 1. So they just have to have a label for that. Starting from 1 all the way to the 8th number. Okay? So I'm starting from 1. I'm starting adding them up from 1 all the way to the 8th. Here's what we have for this series here. I've got 1, 2, 3, 4, 5, all the way to 6 numbers here. So what if I ask you, for example, you guys, what is the, by the way, instead of a sub 1, they use i's here. It doesn't really matter. So what is I 4? Can somebody tell me who lives in the 4th address? 18 will. So basically you just have to keep repeating, you keep adding 3 plus 8 plus 13, etc. all the way through 38, and you're going to find out that you have a summation. It's a series, so you're summing things up, you're adding things up. Either using the S notation here or the sigma notation, they mean the same thing. And it says here also you could use either the sigma or the summation notation. All right. So, in a quick check for understanding here, what do you think? Let's see number 6. What do you think is a common difference in number 6? Somebody give me a common difference in number 6. Yep, difference could be positive, it could be negative, and in this case, it just happened to be that. So, some of you have written down, is it? Yep, that is very true. That's the common difference here. Okay, what do you think is the what do you think is going on here in this number 4 here? How many terms do we have for this? How many terms are you adding in number 4? That's right, Juliana. How many terms are you adding for number 4 for this notation here? You're going from... Yep. Anybody else? How many are you adding here in number 4? How many terms are you adding? You're starting at 1, Yurishi, but how many terms are you adding? Remember, this is a starting, this is an ending point. Yeah, because you're going to add 1 plus 2 plus 3 plus 4 plus 5 terms. That's what it says. You're adding from n equals 1, first term, all the way to the 5th term. So basically you have to add this 5. You're basically adding it 5 times. Okay. I think this is it. This should conclude this short lesson.